Okay, let's start our next problem in theory of computation. Consider the regular language. Okay, and this is the regular language. Okay, we have three ones and then five ones. And there's plus and then there is a star out here. Okay, the minimum number of states in any DFA accepting this language is. Okay, and so what we have a language of the form of this type. Okay, uh, I've done a quick review of what this thing means, and you also know it from your theory class probably. This is a regular expression. You can look in one of the videos. I've explained it a bit what this is and what you infer from here. So, and then what you have to do is basically you have to find the number of states in a DFA, okay, that will accept this language, and you have to find the minimum number of states. That's the key out here. So if you look at this thing, okay, and try to understand what's happening out here, okay, when you do this, so this is 5, okay, and when you do this concatenations, you get a set, okay. So if you do concatenation 0 number of times, you get epsilon string. If you do it once, you get this, and this 5 ones, okay, this 3 5, and then you can do this with itself, so you will get 6 ones, okay. You can do this with itself, you can get 10 ones, and you can do this with itself, you can get 8 ones, and so on, okay. So you'll get a set of strings like this, okay. So what I'm going to do is I'm going to write down the number of ones that you see in this case, okay. So out here you see 0 1, okay, out here you see 3 ones, okay, out here you have 5 ones, and out here you have 6 ones, okay. When you combine this 3 ones with 3 ones, you get 6 ones, and you combine this with this, you get 8 ones, and so on. So these are the number of ones that I have written down here, and this is what you will get when you do this clean star operation on this thing. So this is a regular expression, and it expands to this set. And so let's do one thing. Let's see how, let's try to expand this and see like what sort of pattern do we get, okay. So I'm writing this again. uh, so in the beginning, what do you have? You have something with 3 ones, okay, and you have something with 5 ones. So these two are definitely possible, and you get your epsilon string, you get empty string, so you can also say 0 ones, okay. So this is something you can definitely get. When you combine 3 with 3, you get this 6, so you can get 6 ones, okay, 6 concatenated ones. And you can combine 3 with 5, you can get 8 concatenated ones. You can combine 5 with itself, you can get 10 concatenated ones, okay. When you combine this with itself, when you concatenate this with itself, you get 10, and you can go on this way. You can get 11 when you combine 5 with 6, like this. You can get 11. You can get 12 when you combine 6 with itself, okay. 6 means 6 you achieve by concatenating it with itself, and if you do this concatenation 4 times, 3 3 3 3 4 times, you get 12 ones in your string. So and so on, okay. Now what you see is something interesting out here. As soon as you see this string, okay, as long as you see this pattern, this is a continuous pattern of 3 without a break, 10 11 and 12, okay. As you have achieved this, then there is something interesting that happens, is that then you can achieve every number after this. That means that you can achieve as many number of ones as you want, which is higher than this, okay. And the reason for that is because you have 3 out here, okay. You have 3 out here, and then this 3 is corresponding to these 3 ones, okay. And this 10 corresponds to 10 ones, 11 to 11 ones, and 12 to 12 ones. And then what you can do is you can combine this 3 with 10, okay. When you combine this 3 with 10, okay, so these 3 strings with these 3 ones with these 10 ones, you get 13, okay. And then you can do the same, 3 with 11, you get 14. You can do 3 with 12, you can get 15. So you get another these 3 ones, and then you can do it again, 3 with 13 and 16, and so on. So that is a key point out here, okay, that after this you will get every possible uh, concatenation of ones, okay, higher than these ones. So the key is okay, uh, just a thing, you can definitely get 9 also here, okay. I forgot to write 9 out here, because what you can do is this 3 you can concatenate 3 times and then you get 9. So from here, from 8, 9, 10, you can do the same thing again and again, and you can get these in 3 patterns by just concatenating 3. And you can, so after 8, so that's the key point. Sorry about that, I missed this 9. So after 8 you can get all the possible concatenations of 1 higher than 8. So, and 8 tells these numbers, they tell you the length, okay, the length of the strings that you have, how many ones are there. And with that thing in mind, let's see if we can get a DFA for this, okay, because after that it becomes simple after 8. So what I'm going to do is I'm going to start, so this is my starting point, and I am going to make some states out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, like this, okay. And then what I'm going to do is I'm going to write the number of the length of the strings, okay. So I'm going to write 0 in this. So this is one state, this is 1, this is 2, this is 3. These are different states, okay. 6, 7, okay. I'll write this later, and there is a reason why I am doing that. So this means that you start here, you have nothing, empty string, okay, and you accept it, okay. You definitely accept it. So what you can do is you can definitely make this like this, okay. So this is an accepting state, and then what you can do is you read a 1, you go here, okay. You don't accept it, you read a 1, you go here. So this number inside, written inside these states, tell you the length of the string, okay. And these are the different lengths that you accept, okay. And then you go to 3, and 3 you accept, okay. So for 3 you can make something like this. So 3 is something that you accept, okay. 4 is something that you don't accept. 5 is again something that you accept. You accept strings of length 5, okay. So you accepted 1, 2, you read 3 ones, okay, and you accepted this, okay. This is what we have here. And you accepted 2 more ones, and you read 2 more ones, and then you accepted this, sorry. And then same for 6, okay. So this way you accept 6, and this way you accept 7, okay. And sorry, this way you go to 6, and 6 is accepting, okay, sorry. So 6 you can make like this. 7 is not there, so 7 you don't accept. And then you go, we read one more string, and you go to 8, and you know that 8 is again accepting like this, okay. And then what you can do out here is make it 8 plus. So what this 8 plus means, that all the states 8 and higher than 8 can be read just like this, okay. So what you can give this one thing out here. So 1, 2, 3, 4, 5, 6, 7, 8, and you were at 8. So but you can keep on adding ones, because after 8 there is a continuous sequence of these strings you can get. You can get a string of 9 ones, you can get a string of 10 ones, of 11, and all these lengths are possible. So you remain in the same state, and that's why I call this state 8 plus. That means 8 and all other higher strings, okay. This is fine, okay, and this is a DFA in front of you. But what is missing out here is, this is not a DFA, okay. There's something missing that will make it a DFA, and that is the dead state. You still need a dead state, okay. So this is a dead state. You need a dead state. Okay, you don't need a dead state. Why? Because it's kind of ambiguous. Suppose if it's not given what is the alphabet, if 0 was there in your alphabet, suppose there was 0 present in your alphabet, then you would get, then for all these things you will have to go to dead states and never come out of this dead state. But it is not given in the question that there is a 0 in the alphabet. So So what you can do is you can just stop here. Okay, and can you do better than this? Can you get something that is smaller than this? Can you get lower number of states? And it turns out no. And you can see it's the case, because it's only after 8 that you start seeing this sequence, and you cannot merge any of these two states. So suppose you try to merge 4 and 7, then you will end up in a problem, because from 4, after reading two strings, okay, after reading 3 ones, you end up in 7, which is non-accepting. But if you merge them, then after reading 3 ones, you will accept something. So this is the minimum you can do, okay, and you cannot merge any of the states out here. You cannot minimize this further, and these are uh, 9 states. Okay, so this is the DFA that you get in this case, and that's why your answer is 9 states. You cannot do better than this. Okay, and what else? I don't think I need to say anything else. That's the other thing. It would need 10 states if you had a 0 out here. But I think in the question they should have mentioned the alphabet, that the alphabet is just, it contains just one single one, one symbol 1. There's no 0. In that case, it's fine. 9 states. Okay, so that's the option. The correct option is D.